Okay, so in the first class, we talked about scientific notation and units in measurement. So I wanted to quickly go over the homework from section 5.1, questions 1 through 5. So numbers that have a value greater than 1, when you write them in scientific notation, will have a positive value for the integer in the power of 10. Those that are less than 1 will have a negative value. That's question number 1. Number 2, there's just a list of the values that you get in standard scientific notation. Now, standard means you have a number between 1 and 9 followed by a decimal. That doesn't mean you have 20.3 times 10 to the 6th or something like that. That is not standard form. Standard form only has numbers 1 through 9 in the front. Question number 3, length, the English version of a meter. The usual unit is a foot. If you put a yard, that's fine. That's about the same as a meter. It's a little less. In terms of volume, the English unit of quart, about the same volume in the metric units is a liter. And mass of a pound, well, if you go to the metric unit, I would be happy with either kilogram or grams. Kilogram is closer. A kilogram is 2.2 pounds. Grams are 1,000ths of that, so whatever that would be, 0.022 pounds each or something. But both of those are very common metric units. Question number 4, when you do the conversion, if you have 50 centimeters and then there's 10 millimeters per centimeter, you multiply by 10 to get 500. And finally, you might have had to look up the number of ounces in a liter somewhere, or the amount of ounces in a quart, to see which one was bigger. A liter is a little bit bigger. Okay, so we'll go over the homework, and I'm going to go ahead and take a quick look. Let me just close the current tab, and we'll pop up the notes for today. Okay? Now, you do have a homework assignment. You have a reading of section 5.2, questions 1 through 7. It's due for the next class. Okay? And today we're going to talk about significant figures and error in measurement. Okay? Now, you guys, hopefully Mr. Conklin will hand out everything that you need. I want you to take a ruler, measure the width of a quarter, write down the diameter to the closest tenth of a millimeter. Now, it would be great if you guys could, check yourself against a couple other people and see if you agree. So let me give you a minute to do that. You should all have a ruler, and you should all have a quarter right now. Now, the point of this exercise is to show you you're not going to all agree. I'm sorry, but I guarantee you're not going to all agree. The actual value, according to the US Mint, is 24.3 millimeters. All right? Some of you probably got 24.4 or 24.5 or 24.2. I seriously doubt you all got 24.3. The point is that whenever there's a measurement, there's going to be error. I don't care whether it's human error, like this would be, or maybe there's error in your ruler. I mean, who knows where the error is? But there's always going to be some error in any measurement. Even if you have a digital balance or a digital readout, there's error in the last digit. So first thing you need to understand is in science, when you're doing a measurement, nothing is certain, okay? Every measurement has uncertainty. Some measurement devices have more uncertainty than others. So what we have to do is kind of try to figure out what that means. Now, take a look at these two rulers. Do they both measure to the same amount of uncertainty, or is one of them going to give you less uncertainty? Think about it. Suppose you are right here versus right here. If you're right here, it looks like about 1.7 centimeters, or 17 millimeters if you'd like to do it in millimeters. The thing is it exactly 1.7? Maybe. Might be off by a little bit. So what we usually do is we know that it's 1.7, probably something like right in between here. So we're going to estimate the next digit. So what we'd have is two certain digits. 1.7 would be certain. And we'll have one uncertain digit, which is our best guess as to the space between those two lines, which will, let's say it's 0.3, so 1.73 centimeters. Down here, you can't do that. You can't get as much accuracy. Between 1 and 2, you don't have any more lines, so you're just probably kind of guessing. It looks closer to 2 than 1, so you might be able to say 1.7. You can't say 1.73. You don't have certainty in even your 7 digit. Your 7 digit is still an uncertain digit. Maybe it was 1.8, maybe it was 1.6, okay? So these two rulers differ in their uncertainty, and you'll have a question like that in the homework. Now, Mr. Conklin is also supposed to have a beaker, an Erlenmeyer flask, and a graduated cylinder handy, okay? If you were to look at them, you'll see that the beaker and the Erlenmeyer flask will say plus or minus 5%. It's printed right on them. That is a huge error in science. All right, if you want to try to use something accurately, you need a very small error. Now the graduated cylinder is accurate to plus or minus 0.5 milliliters. So if you have 100 milliliters of water plus or minus 0.5, that's an error of 0.5%. So it can measure a volume like that much more accurately than a beaker could measure 100 mils or an Erlenmeyer flask could measure 100 milliliters. So whenever we're trying to do something in science, when we have choices, we always try to pick the device with the least amount of uncertainty. That is, if we're going to measure something. Now, in measurement, all of the certain digits and the first uncertain digit are considered significant figures. Now, if you go back here, like I said, if you're in between 1.7 and 1.8, you know the 1 is significant, you know the 7 is significant because you can see them. What you're not certain about is how close to the 8 you are or how close to the 7 you are. So that's why I said 1.73, that last digit is a guess. Here on the bottom one, it's roughly 1.7, but it's, could be 1.8, might be 1.6. So you only have 2 digits there that are considered significant figures. 3 digits versus 2 digits. So one thing you might notice is the more divisions you have, the more significant figures you'll have in a measurement. Now, in addition to having significant figures from a measurement, what happens if we just have numbers written down, okay? If you just have numbers written down, how can you tell if a digit is significant? There's a few rules. Now, Mr. Conklin is also going to hand out a handout for you to look at, okay? And that handout basically says the stuff that's on the next slide. Now, all non-zero numbers count as significant figures. So example, 1435, it has no zeros in it anywhere, not at the beginning, not at the end, not in the middle. All non-zero numbers always count. So it's 1, 2, 3, 4. It has 4 significant figures. Leading zeros never count. So for instance, take a look. If you were silly enough to write 123 as 0, 0, 0, 1, 2, 3, it only has 3 significant figures. Again, the zeros at the beginning, which are called leading zeros, don't count. Captive zeros are ones in between whole numbers that are non-zero, okay? So here, there's 2 zeros, but they count as significant figures because they're in between numbers that aren't 0. So this one has 5 significant figures, 1, 2, 3, 4, 5. Finally, trailing zeros only count if the number has a decimal point. So for instance, 1.0010 has 5 significant figures. How many significant figures would the number 100 have? Think about it for a minute. It has 1 significant figure. It's got 2 trailing zeros and there's no decimal point. What if you had the number 100 and the second zero had a decimal point after it? Aha! all of a sudden those two zeros are no longer trailing zeros in a number without a decimal point. There's a decimal point there, so now all three of them count. So 100 followed by a decimal point has three significant figures. Okay, let's look at how significant figures propagate in calculations. We have two sets of rules. One set of rules is for multiplying and dividing numbers. Another set of rules is for adding and subtracting. They're different. Now, for multiplying and dividing, whichever number in the equation has the least number of significant figures will determine how many significant figures are in the final answer. What does that mean? So let's take a look here. We got a board. It's got a length and a width and a height, so it's a rectangular board. In order to find the volume, you have to multiply length times width times height. Now take a look at our values. The length has 5 significant figures. The width has 4. The height has 3. So we'll do the math just like we normally do with a calculator, multiplying all three together, but in the end, we have to round it to 3 significant figures. So if you use your calculator and you don't even go to a decimal, but you just go to the ones place, you can see there's all sorts of numbers here, 222, 856, right? Now, how many significant figures does this have? The first one has 5, the second one has 4, third one has 3. We have to round this number to 3 significant figures. Now, the rules for rounding are standard. If you have a 5 or greater here, that 2 will round up. If you had a 4 or lower here, it would round down and it would stay a 2. Because this is an 8, we have to drop the 856, make it zeros, and we have to round the 2 to a 3. So 223,000 is the correct answer. You can also write it in scientific notation. 2.23 times 10 to the 5th cubic centimeters is also has 3 significant figures. You should remember how to write numbers in scientific notation from last class. Now let's take a look. Again, the rules for adding and subtracting are different. When we're adding and subtracting, what we do is we look at the number with the fewest decimal places, right? So here's an example. We've got 12.11 and 18.0 and 1.013. The one that has the least number of decimal places is 18.0. So we add everything up, then we round to that position, to 1 decimal. And when we round to 1 decimal, since now the 2 is less than 5, we round down, so it's going to round to 31.1. And our answer will only have 1 decimal place. Okay? The middle number only has 1 decimal. That's the one that's determining how we have to round this equation. Okay. Now, we're going to do this Who Killed Mr. Jackpot challenge. So I'm going to try to show you how to do this, okay? As best I can, anyway. You're going to work in, like, let's say groups of 2. You can have a group of 3 if we need a group of 3. It doesn't really matter, okay? So Mr. Conklin will hand out the Jackpot challenge. What you'll see is it's 2 pages, okay? One page has the problems. The second page, if you take a look, has a whole bunch of values and then a name next to it, okay, of something. Okay, now this is how you play. You're going to have to solve all of these problems, all 30 problems. Every time you solve a problem, you will look at the second sheet and you will cross off any person, place, or thing that matches the value of your answer. So let's take a look at question number 1. So 2.770 plus 12.4. Now, if we were looking at that, not notes, we want text here. If we were looking at that, this is how we would round it, okay? 2.770 added 12.4, got to round it to 1 decimal, so 15.170, but then when we round it to 1 decimal, it's 15.8. 15.2. So why don't I make that a little bit bigger so we can see a little bit better. All right, there we go. Rounds to 15.2. Now, what do? We go down to the bottom and we try to find 15.2. Oh, take a look. Here's 15.2. Okay, so what do we do next? We come up here and we look. It said Miss Mint. We cross off Miss Mint. Now, you're going to keep doing that for all 30 problems. Eventually, you will have everything but one crossed off under who, what, where, and why. And the one that isn't crossed off will be the who, the what, the where, and the why. If you get all 4 correct, you get candy. I'll make sure that there's candy in the room, and you'll be able to, Mr. Conklin can give you some if you turn it in. He'll have the key, so he'll know what's the correct answer. Okay? So that's what you're doing the rest of class. All right, now let me go back to the notes just to show you everything that we just talked about is also here. So figure out who, where, why. It says if you're first, you can win candy. But if you can get it legitimately, I'll let anybody have candy. Again, how do you play? You add the numbers, round it properly, and then in this case, you find the thing that you need to cross off that matches that number, which is Miss Mint. You cross her off, and then the 4 things that are not crossed off will give you the who, what, where, and why. Now again, don't forget. Besides doing this is actually important because this is good practice. Besides doing this, don't forget that you have homework due. Section 5.2, questions 1 through 7 on page 142. So make sure you take a look at the assignment.